Alright, welcome to the second video on molecular structure. In this video we're going to be going over VSEPR theory. That's valence shell electron pair repulsion. So basically what that is the repulsive interaction between electrons forming a specific geometric shape. Now we're going to be doing in this video looking at molecular models to help you better understand this. Now in the previous video we looked at the AXE method of counting electrons. That's going to be applied here because we're going to be linking a specific geometric shape to an AXE configuration. So the first one we're going to look at is the AX2 configuration. So the AX2 configuration is going to give us a linear molecule. So as we see here, here's a molecular model of it. We're going to have one central atom and two surrounding atoms. Again, the electrons in this molecule want to be as far away from each other as possible. With the AX2 configuration, that's going to be on the opposite side of the central atom. So we're going to have a linear molecule giving us a 180 degree bond angle. The next one we're looking at is an AX3 configuration, giving us a trigonal planar molecule. So AX3 configuration with the trigonal planar molecule. That's going to look something like this. So we have three surrounding atoms, one central atom, trigonal planar. Now trigonal planar gets its name, if we hold it like this, we form a triangle. So that's where it gets the trigonal from. Planar because it's flat on the plane. So trigonal planar. The bond angles you're forming here are 120 degrees. Again, they want to be as far away from each other as possible. If we have a 360 degree circle, divide that three ways, it's going to give us 120 degrees. So trigonal planar has a 120 degree bond angle. The next configuration is going to be an AX4 configuration. It's going to be a tetrahedral geometric shape. It's going to look something like this. 1, 2, 3, 4 surrounding atoms, tetrahedral. This molecule gets its name because of the four surrounding atoms giving it a prefix of tetra, hence the name tetrahedral. Now, the bond angle it forms, if we look here, we have two on the plane, one going at you, one going away from you. This is the furthest they can be from each other. They're going to be forming a 109.5 degree bond angle between each of these atoms here. So 109.5 for the AX4 configuration of tetrahedral. Okay, going down, we're going to add one more surrounding atom, giving us an AX5 configuration. AX5 configuration, 1, 2, 3, 4, and 5. The name of this molecule is trigonal bipyramidal. Now this molecule gets its name because if you look at it from the plane, we're going to have a triangle just like we formed in trigonal planar. So we're going to have the triangle, trigonal planar, and then if we look at it this way, it's going to form two pyramids. One pyramid up here, one pyramid down here, giving it a bipyramid shape here. To help you better visualize that, there we go. So we have one pyramid up top and one pyramid at the bottom. So trigonal from the triangle on the plane, and then the bipyramid that it forms up top. So trigonal bipyramidal. The bond angle that we're going to be forming here, it's going to be the same bond angle as in trigonal planar, 120 degrees here. If we look like this, we're going to have a 90 degree bond angle. So between the axial and the equatorial atoms, we're going to have 90 degrees. Just the equatorial ones, we have 120. So 120 and 90 degrees for the trigonal bipyramidal. Trigonal bipyramidal. Alright, so the last one down the list is going to be an octahedral molecule. Now the name of this one is a little less intuitive than the other ones because of the prefix octa, yet it only has six surrounding atoms. 1, 2, 3, 4, 5, 6. It gets the prefix octa by the number of faces it makes. So this actually makes 8 faces. To better demonstrate it, I'm just going to put the pyramid like we did before and count the number of faces. We're going to have 1, 2, 3, 4, 5, 6, 7, and 8. So the 8 faces it makes gives the prefix octa, hence the name octahedral. So an AX6 configuration is an octahedral molecule. The bond angle it's going to form between all the atoms here is going to be 90 degrees. 90 degrees here, 90 degrees here, all the way around 90 degrees. Okay, so what we're going to have now, we're going to have down the side is going to be the steric number. Now the steric number is just going to be the number of surrounding atoms plus the number of electron lone pairs. I haven't done any with electron lone pairs yet, so the steric number is simply the number of surrounding atoms. So here we have 4 surrounding atoms, giving us a steric number of 5, 6. So steric number. So up top, I'm going to have the number of lone pairs. So here, the first one, we don't have any lone pairs. We're going to do some 1, 2, 3, and finally 4. So electron lone pairs up top. Okay, so the first one we're going to look at is an AX2E1 configuration. So again, steric number 3, because we have 2 surrounding atoms and 1 electron lone pair. It's going to give us a molecule that looks like this. The name of this molecule is bent. We have a bent molecule. What I want to point out about this molecule is that the bonding angle that's going to form is going to be approximately the same one as the trigonal planar, 120 degrees, approximately. Depending on the molecule, it might be a little more, it might be a little less. As a general rule of thumb, though, for every electron lone pairs that the molecule has, you're going to take away about 2 or 3 degrees. So a molecule like this will have approximately 117 degree bond angle. So for an AX2E1 configuration, we're going to have a bent molecule. Alright, the next molecule we're going to look at is going to have an AX3E1 configuration. So that's going to be a steric number of 4. We're going to have a molecule that looks something like this. So the name of this molecule is trigonal pyramidal. Now we guess this name because if we look at it like this on this plane, we're going to form a triangle. But if we flip it over this way, it's going to form somewhat of a pyramid. So hence the name trigonal pyramidal. Again, the bond angle here, instead of being the regular 109.5 degree bond angle of a tetrahedral, for every electron lone pair, we're going to take away about 2 to 3 degrees. So here, we're going to have about 107 degree bond angle to a molecule like this. Alright, so AX3E configuration, trigonal pyramidal geometric shape. So next we're going to stay with the steric number 4. We're going to look at an AX2E2 molecule. So here, just like before, we're going to have a bent molecule. Again, the bond angle between this one here, we're going to take away about 2 or 3 degrees for every electron lone pair. So instead of 109.5, the bond angle here is going to be approximately 104. So the geometric name for an AX2E2 configuration is going to be bent. Alright, so now we're going to look at the AX5 configuration. So the first one we're going to look at is with 1 electron lone pair. So that's going to be AX4E1. So 1, 2, 3, 4, and 1 electron lone pair. This one was cleverly named Seesaw. So the name of this geometric shape is Seesaw. It's cute. Alright, so AX4E, Seesaw geometric shape. Moving down, we're going to have now AX3E2. AX3E2, this one also cleverly named T-shape. Alright, if we continue moving down, AX2E3, we're going to have a molecule that looks something like this. 2 surrounding atoms and 3 electron lone pairs. We're going to have, once again, a straight linear molecule. So for an AX2E3, we're going to have a linear geometric shape. Alright, so now moving to the steric number 6. The first one we're going to look at is an AX5E1 configuration. So 1 electron lone pair. So we have a molecule like this. AX5, 1, 2, 3, 4, E1 configuration. Now the name of this molecule, if we look at it on its plane, we're going to form a square. If we flip it over this way, we're going to form a pyramid like we had before. So we form a square and a pyramid, cleverly named square pyramidal or pyramidal. Square pyramidal. Square pyramidal. So AX5E1 configuration has a square pyramidal geometric shape. Square pyramidal. Alright, we're going to continue moving down the list, giving us an AX4 E2 configuration. So 4 and 2, steric number 6. So we're going to have 1, 2, 3, 4 surrounding atoms and 2 electron lone pairs. So this one, if we look at it as plane, we're going to form a square again. The name of this molecule is square planar. Square planar. So an AX4E2 configuration has a square planar name. Alright, if we continue moving down the list, we're going to take away another bonded electron and replace it with a lone pair, giving us an AX3 E3 configuration. You probably guessed the name of this one, T-shaped. So T-shaped. Alright, finally, if we remove another bonded electron pair and replace it with a lone pair, again, you probably guessed it, a linear molecule. So AX2 E4 configuration is going to give us a linear molecule. And there you have it. This is our VSEPR chart using the AXE model of it to name all the geometric shapes.